So we have reached our final talk of the day and of this track of this conference with our second lady lecturer of the day, Sara Krk, who is a data scientist at Outfit 7, and she will demonstrate to us how we can automate everyday work using their own example. I would remind you to pose your questions through the platform, and Sara, the floor is yours.
Thank you. Is this working? Yeah, okay. Hello. Um, is your calendar full of meetings so it's difficult for you to do all of your tasks? Are you buried in small tasks and can't start working on a new, big, more exciting ones? That happened to me and my team, so I came up with a solution. Try to automate as many everyday tasks as possible. When I started working at Equipa 2, subsidiary of Outfit 7, 3.5 years ago, the analytics department just started to exist. In the last year, we got a lot of trust from other departments, which means we have a lot more work, but also a lot more interesting problems to solve and questions to answer. At the moment, we are a team of 10 data scientists working on the different aspects of the gaming industry. We have people from different backgrounds like mathematics, financial mathematics, computer sciences, psychology, and electrical engineering. A big part of the team is working on users' behavior analysis, and it is our job to understand how users behave in our apps, how game features perform, always looking to prepare the best strategy for games updates, and working closely with other members of the game team to implement them. We are not only checking high-level metrics like how many users do what, but we also try to dig deep to understand why. That's why it's super important to automate as many, all very important high-level metrics as possible. So to first tell you a little background, in the gaming and web industry, A/B testing is a very common experiment to compare two or more different variants. Fun fact, we just ran a test with 16 different groups. So we select two groups of random users that don't differ in any metric, and we serve them each other variant. So for example, we have here group A with the green icon and group B with the pink icon. So in one group, they see the green one and the other one, pink one. And here we see also the results. So on the green one, we have 500 clicks, and on the pink one, 400. So because these two groups shouldn't differ in anything, the difference is most likely to come from the icon. So if we serve the green icon to all users, the clicks should increase. So we measure games performance with many different metrics. 3 of the most important ones are retention, so percentage of users returning to the game several days after the install. Session duration, how much time users are spending in the game. Lifetime value, how much value or revenue average install is generating. So every time we did a report, we put all these 3 metrics, and each one with multiple visualizations, to the report. So looking back, our team was constantly answering the same type of questions, doing similar reports for updates, and of course for A/B tests. And don't be fooled, we still do all of this. The only difference is that now we have data prepared in a way that all the results are just one simple query or even just a click away. So the biggest problem in our team were A/B test reports. Because our company is quite big, we cannot afford to make a change that would drive our users away and therefore decrease our revenue. So we are testing different scenarios all the time to balance between amazing user experience and, of course, revenue. Before the automation, one data scientist could analyze a handful of tests a month and maybe one bigger task. But now, with this automation, one can do a couple a week with also one bigger project that they oversee. So which are the most important steps you need to take? The first one is choose what to automate. That's quite obvious. The second one is everyone on the team can update the code, and they should do that safely. Create a daily job to execute the code. Create an easy setup environment. And lastly, create nice UI for the results. So let's see how we tackle this in our team. So the first thing is choose what to automate. Because we wanted to automate A/B test reports as much as possible, we took all metrics that aren't app-specific. So the most important ones, retention, session duration, and lifetime value. And that was like the first step. So because we have terabytes of data a day and in more than 2 billion rows, we also need to we also need to optimize our storage and querying. So that's why we also decided to create user aggregates to decrease cost and time of querying. So we have a daily job that creates user aggregates every day. We have one table a day with one line for one user. This means that this is the first user here. Wrong button. This one. So here is like one user opened the app 17 times. And instead of having 17 rows for that user, we have just one row with a column that tells us that he opened the app 17 times. So we have just limited amount of metrics that we check every day. So we also added here all of them to have all the data ready for a simple query. And also, if one A/B test shows that one metric is missing, we can easily add it. And with this, we decrease the size of our tables to just 0.5% of the original. So this doesn't only mean less size, also mean less cost of querying and shorter execution time of queries. So win-win-win. The second step is that everyone on the team can update the code. This is a very important step because everyone on the team should be able to add something to the code or debug it or change something. So all users, all team members should know the language. Because we have so much data every day, we use BigQuery from Google to prepare data anyway. So the only thing left is some additional visualization and pivoting. Half of our team was using Python and the other half was using R. But we all sold our heart to ggplot from R, so everything now is in R. So now that we know which language the code should be in, we also need to make sure that they can update the code safely. Before, we were using IPython notebooks on Jupyter, and that is far from safe. If two users are, if two team members are changing the same notebook, the result is a mess. So with having the code in R, we also added a version control using Git. So now we have everything not on Jupyter anymore, but we can download the code and test locally. So now that we have the language and everything written down, the code, we need to create daily job to execute the code. So because we want to decrease manual work as much as possible, we definitely need to create a daily job, not to run everything by hand. So before we were using IPython notebooks and we had a couple of problems. One of them was that we had so much data to manipulate and plots to plot that we had multiple notebooks just for one A/B test. So we need to figure out how to run one notebook from another. And because these are notebooks and not files, that's pretty complex. And if anyone here needs this, we use a combination of mbconvert and mbformat libraries in Python. But along with moving everything under Git, we also left IPython notebooks behind. And now we use Airflow Scheduler, which made the development of the code way easier, and also now we have error handling, which we didn't actually had before. And the other problem for IPython notebooks were that the execution of the code was so long because we had so much data. So we also did these user aggregates, so we decided to add them to the A/B test script as well. And now with both these things, so less, I'm sorry, less data, we decreased the time from more than 1 hour per test to just a couple of minutes. So now that we know which metrics the daily job needs to do, we still need to make sure for, it still needs to know which A/B test it needs to run for. So we are using a lot of Google features. One of it is Google Sheets. So we just started to write things here. So here is an example of an A/B test. We have the title, the reporting ID with which we segment users into which group, the app name, then we have analysis index. I will tell about this a bit later. And these nice groups is the description of groups, what do they do. And additional filters is the same as analysis index. But the problem we had before, we had IPython notebooks, and access to Google Sheets is pretty difficult without writing your username and password somewhere on the server, which is not safe. So we used a neat feature from Google that lets you access Google Sheet through BigQuery. Every analyst in our team has access to that. So if one adds an A/B test, they just need to write it here, and that's it. So about those two columns, analysis index and additional filters, we also added a feature which lets you run the script for different clusters. So here, for example, we have country code equals US. So the whole test will be added. This filter will be applied to all plots automatically. So we can check A/B tests for different clusters to see how they perform, because users are different in US than they are in China. So now that we have everything in the daily job that does everything, we just need to make a nice UI for results. So we have a dashboard. We chose Shiny from R because we use it for all other things as well. So here we have a drop-down menu for select app, select A/B test, and also these subtests, so the US only. And because we had so many plots, we split them in multiple categories, so users plots, retention plots, engagement plots, video plots, etc. This A/B test dashboard isn't interactive, but others are. We use also this for different metrics that we calculate from user aggregates. For example, how retention, the percentage of users returning back to the app several days after install, is changing due to seasonality or updates or featuring. So here is a short video for the dashboard. When we started with the dashboard, we had very little metrics, but we started adding them a lot. And this is the fun thing about this is that we can add a lot metrics here just to analyze the test better, but we don't need to add them all to the report. I don't know how to start the video. No? Anyone? Oh, okay. So this is the same as before, the same test. This wasn't a fun test, I must say, because there's no difference. Okay, so when we start running a test, a data scientist just needs to add a line to a Google Sheet, and everything is done in the next morning. So the daily job collects all aggregated data, calculates statistical tests, plots everything, and saves plots that are then shown on the dashboard. And that's it.
Thank you.
That was shorter than expected. I think I missed
You
something.
promised 15 minutes. I think you went a bit longer. So we have one question. Somebody suspicious. What are the pitfalls of having automated analysis? Is it not dangerous to blindly trust the results and not think about them?
Well, at the beginning, that I think happened, but actually with all this extra time that we have now, we can take all the time to actually look at the plots. So before it took us like 1 hour to plot 4 retention plots, but now we can take 1 hour to understand what all groups are different. So if there's any difference. Also, I need to tell you something. No, it's okay. I'm sorry.
Somebody has written another question. How do you design the process and accept Airflow that tools what tools have you used for it?
Well, we used Jupyter Notebooks, so mostly Python for everything. And now that we are in Airflow, we use Python as well. So, well, Python for execution, but then the code is in R. I don't know how they did it. They did it in backend. It's some black magic that they had to implement something that the R code can be run, but I don't know.
Do you have some statistical tests for KPIs, and what are the main KPIs?
So the main KPIs are, as I said before, retention, session engagement, session duration, and lifetime value. Everything on this dashboard is everything has calculated statistical tests, which I would tell you about, but I forgot, so I'm sorry. But yeah, so the test that I showed...
we do have a little bit more time if you want.
No, it's just everything is distribution tests, and that took a lot of time as well. So we decided to move them to BigQuery, which doesn't have function for distribution tests, so we had to make our own. But yes, we have all plots are statistical, some distribution tests or z-tests or whatever. So, but the example I showed was no difference, so that's why everything was like no difference. I'm sorry for that.
2 more questions arrived in the meantime. Do you automate some other processes as well in your company?
Well, this is the A/B test. We also automated updates reports. So when an update goes out, we again check the same metrics, and we have all those plots on a different dashboard, and we just copy them. But I think now we will start with more, because this was just done 1 month ago. Everything was moved to Airflow, but it took us 1.5 years to do that.
What happens on devices after A/B test is done? Are all users returned to original version, or a version that show better performances is set for all users?
That depends on the test. If the test is, for example, in economy, and we decrease prices, we won't increase them. For those users, we will just let them be, and we change those for new users only. But sometimes we just change it for everything, depends on the test. But economies are always a bit tricky.
And the last question, how long do you run A/B tests usually?
Again, depends on the test. If the thing that we are testing happens super at the beginning of the game, we will test it just for a couple of days. But if it's like a new feature that changes economy and everything, we will run it for a longer time. But since we are now in super demand of A/B tests, I don't think we take a lot of time, so it's like a couple of weeks for the last cohort to have a couple of weeks of data.
Thank you very much. And before you leave, I would like to give you the certificate on behalf of the organizers. Thank you for contributing.
Thank you.